Today, I will discuss about the fluvial morphodynamics and channel adjustment. Morphodynamics is a process by which morphology affects hydrodynamics in such way that influence the further evaluation of the morphology itself. Fluvial morphodynamics refers to the study of the interaction and adjustment of the fluvial system and fluid hydrodynamic processes. Hydrodynamic processes includes flow, energy and sediment entrainment. Morphological change in a fluvial system deeply sensible to operation of the hydrodynamic processes. Entrainment of sediment depends on stream power, bed load and gradient. Now the sediment is considered as time dependent coupling only because entrainment of sediment associated with a particular time lag. Now the boundary condition of the hydrodynamic forces changes frequently. That is very common and frequent incident in a channel. Another important thing. What is the another important thing? That is the dynamic changes in morphology. That is also associated with the fluvial morphodynamics. The study of land use change due to the erosion and sedimentation is also an important concern of the fluvial morphodynamics. Morphodynamic processes are associated with feedback mechanism that may be positive and negative and threshold condition of the fluvial system. Now the adjustment of channel form to the tectonic changes. How the channel is adjusted into the tectonic changes or tectonic influences. Tectonic event that has the influence on landscape, that is in two types. One, it can be in upliftment of landforms. It must be in subsidence or right. If it is upliftment, otherwise it is subsidence. Now the tectonic event influences of channels. How it is happening. Base level of erosion and its changes with upliftment and subsidence of landscape. Second point is the formation of erosional features. Third is the alluvial deposition. Fourth is the accretional topography, and it has great influence on the river profile, that is the long and cross profile. Now the tectonic activity and base level of erosion of the channel. Upliftment of land leads to lowering of the base level of erosion. That is very crucial and important. That is, the lowering of base level of erosion is associated with the upliftment of landform. Then lowering of base level of erosion provides condition for nick point formation. Nick point has been formed due to the lowering of the base level of erosion that has initiated by the upliftment of land. This situation breaks equilibrium condition in river long profile. River terraces and alluvial fan preserve deformational history of continental transform plate boundary throughout the geological past. Base level is lower level of water into the channel. That is definition of base level. That base level is considered as the lower level of water into the channel. Now the base level is maximum limit below which flow of water cannot erode. Channel cannot deepening its beds. Now when channel achieves base level, then channel widening process starts, but by deep sidewall erosion that you can consider as the side cutting of the river bank. If river drains its water towards the sea, then local sea level is its desired base level. That is called ultimate base level. When river erodes its bed locally, then it tries to achieve the local base level. This is another type of base level. We can find that there is two type of base level, is general ultimate base level and another one is the local base level. Now the base level of erosion of a river is generally two in types, that I have already told, ultimate base level and another one is the local base level. Now another important concept, that is the adjustment of channel forms to climatic change. The climate change is associated with the fluvial geomorphology in two ways. One is glacial and another is the interglacial. If discharge increases, that leads decrease of sediment size in downstream. that also leads to decrease of channel gradient. In this situation, channel long profile has been adjusted to achieve equilibrium. That is called profile of equilibrium or graded profile. Earth history is associated with several glacial and interglacial periods. Glacial periods leads sea level fall and interglacial periods constitute with the rise of sea level. The Earth also has experienced one of the greatest glaciation in last 2 million years. The waxing and waning of ice sheets lowered and raised sea level as more or less than water on the Earth's surface was locked up in them. Intensity and duration of all glacial and interglacial period were not equal. Sea level fallen up to 130 meters from the present condition during Pleistocene glaciation period. Now the changes of climate condition in the world, in the earth, that leads to the changes in discharge in the channel. Changes of climate condition is also associated with the changes in nature of weathering and mass movement in the river valley. Influence on amount and type of sediment load in the channel has been initiated by the climatic condition. Changes of climatic condition also associated with the local slope, channel gradient, sedimentation on the river bed, terrace formation, rejuvenation and formation of the neck point and incised meander. Now, another important concern, that is the adjustment of channel form to sea level change. Sea level change has direct and indirect effect on drainage system. Channel has to adjust continuously with the change of sea level. Changes in base level of erosion and increase or decrease in drainage basin area is directly associated to the rise or fall in the sea level. Now the fact of contemporary sea level rise. What are those facts? That is, sea level rises over 8 inches, that is equals to 23 centimeter during 1880 to present day. Sea level rises 3 inches in last 25 years. Sea level rises at rate of 1.13 inch, that is equals to 3.2 millimeter per year. Sea level is rising at a 3.2 millimeter per year. Now the major causes behind the contemporary sea level rise. What are those causes? That is, one is the thermal expansion due to the increase of sea surface temperature, and another one is the melting of land-based ice, that is the glacier ice sheet. Now the impact of sea level rise on the drainage basin. What is the impact? Sea level rise can reduce drainage basin area. Sea level rise brings greater aridity in the basin area. Sea level rise reduces runoff in the basin area. Now sea level change and related mechanisms. Rise of sea level leads to the reduction of drainage basin area. That leads to great aridity. That also leads the reduction of runoff. In the opposite sides, fall of sea level, that can enlarge drainage basin area and that can increase drainage basin relief and increase the potential energy available in the landscape. Now the evidences from the historical past regarding sea level change. The sea level fluctuation in late Cenozoic caused major shift in the drainage area, and the periodic submergence of extensive drainage system in the relatively brief intertools of high interglacial sea level such as we are experiencing at the present day. Sea level fluctuation in Quaternary geological age leads lowering of base level up to 100 meter during last 1 million years. Large-scale valley initiation along the continental margin has been promoted by the lower of base level. Successive erosion takes place with the formation of neck point and intensive down cutting. Now the valley aggregation. Valley aggregation has been buried of inside valleys and huge sedimentation carried by the perennial river due to the rapid melting of the high altitude glaciers. Aggradation process is called as the process of alluviation. Aggradation is a geological term popularly used to represent a process of increased elevation of land through rapid sedimentation by a dedicated river system. Aggradation occurs when supply of sediment is greater than the capacity to transport. Now, after the end of ice age, during Holocene temperature rises frequently that leads spontaneously melting of the high altitude glaciers. Now what's happened? Upstream water sources of perennial river increased. Stream power increased with increase of discharge in the channel, leading with excessive carrying capacity of sediment load towards the downstream and deposited in the less slope foothill area due to the loss of energy of our sudden change of slope. Mississippi River is the best example of this river aggregation. Mississippi Valley has been produced by the deposition of huge glacially derived sediment carried from the upstream, enhanced by the melting of the Laurentide ice sheet, that is one of the important glaciers. Some result has been derived from the several dynamic research work done by terrace deposition in the lower Mississippi River Valley about the phases of sedimentation and sediment distribution with episodic valley initiation, which are associated with the fluctuation of sea level in the last Pleistocene age. Impact of quaternary sea level change on drainage basin can be easily explained through the referenced Amazon River system. In Amazon River system, the river was deeply entrenched during the last glacier age, when the sea level was low, but the transformation has been observed in the lower stretch of the Amazon River due to the rise of sea level during the last glacier period. But when sea level gets stabilized during Holocene age, sediment behavior has been changed. Due to this wide low gradient floodplain has been spotted at the lower course of the Amazon River. Now frequent accumulation of sediment at a floodplain sedimentation blocks the mouth of the tributaries of the lower Amazon. When the vertical movement of land is greater than sea and relative fluctuation in sea observed, then it has been significant effect on drainage system, and that also depends on the nature of coastal deformation. Hence, here the tectonic force and sea level change both operating together. Now the sea level change and river hydrostatic consequences. Fall of sea level that reduce water load in continental margin that flex upward. Rise of sea level maximize the sediment load. Landward reversal of river course with less discharge and low coastal gradient has been observed at the Rhone and Nile River during late Miocene because the decision of the sea level change. Mediterranean Sea cause flexural swap in its northeast and southeast margins. Major shift in a drainage basin area and periodic submerges of extensive drainage system due to the frequent fluctuation of sea level has been observed in the late Cenozoic era. Now, the effect of sea level change in the drainage system or drainage basin area is concentrated on its base level of erosion. Another important thing was, what is that? That is the shoreline migration is also an important impact of sea level change. Other related factors of shoreline migration are coastal geological configuration and beach geomorphology. Now, the stationary condition of land, and when the sea is rising or falling, that is the single operation. But when the land is rising or falling and sea is stationary, that also a single operation. But when land is rising or falling, that is operated, and sea also operated, then it is operated together. That is the dual operation. Now the association of base level and sea level change. What is the association? One is the position of delta. Now the delta formation process. Now the formation and transformation of river trace. Now the discharge and stream power. then time and intensity of sediment load. Now, and lastly, the long and cross profile. If the base level falls below the continental shelves, river may form a plain of braided rivers until headward erosion penetrates enough inland from the shelf break. Now the changes of base level. The negative changes of base level is associated with the fall of base level. That is also associated with the readjustment of river profile through what process? One is the rejuvenation, then the formation of neck point, migration or demolition of the neck point, abandonment of the river terrace, fluvial terrace, and modification of terrace. Now the progradation of delta at low laying depression area and a progradation of river sediment at a lake or sea. Those are associated with the fall of base level, that is negative change of base level. Now the positive change of base level, that is the rise of base level. That is associated with river aggradation and drawn lower course of the river. The ria has been formed due to the positive change of base level or rise of base level. Channel it can bury the channel by the alluvium deposition, and it can form a wide active floodplain. Now the adjustment of channel form to land use change. How it is happening? That is the mechanism of land use change. Second is the afforestation and deforestation. It may be happened. Then the construction of the big dam, construction of small dam, construction of the embankment, modification of alluvial fan, anthropogenic utilization of the fluvial terrace, floodplain modification, construction of road, contraction of hydel power plant, agricultural activities. Those are the initial factors that can affect the channel forms through the land use. The channel reaction towards the adjustment. Anthropogenic activity has greater influence on transfer, storage, and yield of the sediment in many discharge basins globally. It can modify channel behavior towards the morphodynamic changes. Various factors are deeply related to the change of channel form due to the land use on the basin area. Now the channel forms has been affected by the local techniques of anthropogenic utilization of the land. Longer term, according to Rowe-Charlton, longer term effect of land use change may be seen from the fluvial records that preserved in the valley deposit. According to Starkill, he has discovered various phases of accelerated valley floor sedimentation in the Central European Valley, which corresponds to the deforestation and land use change during late Bronze Age and most extensively during the Roman time. Now the passive land use factor. What are the passive land use factor? That has effect on the channel adjustment. The passive land use factor are the deforestation, urbanization, mining, quarrying sand from the riverbed, construction of dam. And the active land use factor that has great influence on the river adjustment or channel adjustment, that is the agricultural land in the agriculture practice in the floodplain area, any type of construction within river migration zone, construction of road, construction of rail line, rail bridge, construction of embankment. Those are some references. You can go through this for further studies.